Look at this path. Every asteroid, every comet, every rock we knew belonged to the sun. This one did not. It came from another star, cut through our solar system, and escaped. Then it did something worse. It accelerated. No engine, no tail, no visible gas, no dust plume. Nothing a normal comet uses to push itself through space. We couldn't photograph it properly. It was too small, too dark, too fast. All we had were brightness measurements and trajectory data. And both were wrong, in exactly the way you do not want a first contact with another star to be wrong. By the time we realized what we were looking at, Oumuamua was already leaving forever. And 8 years later, the question is still open. What exactly passed through our solar system in 2017? Oumuamua entered our solar system from above, descending at roughly 33 degrees relative to the plane of the planets. It came from the direction of the constellation Lyra, traveling at 26 kilometers per second.
On September 9th, 2017, 40 days before anyone noticed, it made its closest approach to the Sun, passing inside the orbit of Mercury. The Sun's gravity bent its path, and it swung outward toward the constellation Pegasus. By the time we spotted it, it was already leaving. We had a window of weeks, maybe days, and then it would be gone, forever. So every telescope we had turned to look. And what they found made no sense. Oumuamua's brightness changed dramatically every few hours, not a little, by a factor of 10. That meant its shape was extreme, either a long, thin cigar, roughly 8 times longer than it was wide, or a flat pancake, like a disk. No natural object in our solar system has ever been observed with proportions like that. Its surface was dark and reddish, consistent with organic material or radiation-battered ice. It was tumbling chaotically, not spinning cleanly like a healthy asteroid. Something had knocked it off balance, possibly billions of years ago. And there was no coma, no tail, no gas, no dust, no outgassing of any kind. It looked nothing like a comet, but it wasn't behaving like an asteroid either. And that's when one team at NASA looked at the trajectory data one more time and realized we had a much bigger problem than the shape.
In June 2018, a team led by Marco Micheli published a paper in Nature that changed everything. Oumuamua was moving away from the sun slightly faster than it should have been. Not by a lot, but measurably, consistently faster. A tiny but real non-gravitational acceleration. For a comet, this would be normal. Comets outgas. They release jets of vaporized ice that act like tiny thrusters, pushing them off course. But Oumuamua showed no outgassing. None. Zero. The Spitzer Space Telescope looked for infrared emission from dust. Nothing. The Hubble and ground-based telescopes searched for any trace of a coma. Nothing. Something was pushing Oumuamua. Something that left no signature, no trail, no heat, no dust. Something invisible. And that's when one of the most respected astrophysicists at Harvard stopped playing it safe. If you're still with us, good. Because this is where the story stops being about physics and starts being about something most scientists won't say out loud. 7 months after Micheli's paper, Harvard astronomer Avi Loeb dropped a bomb.
In a paper co-authored with Shmuel Bialy, he proposed that Oumuamua might be a light sail, an engineered, ultra-thin structure pushed by solar radiation pressure, possibly debris from an extinct alien civilization, possibly a probe. His argument was logical. If Oumuamua was extremely thin, on the order of millimeters, then its surface-to-mass ratio would be enormous, and solar radiation alone could account for the entire anomalous acceleration. No outgassing needed. The flat, pancake shape, consistent with a sail. The silence, consistent with a derelict. The scientific community's reaction was fast and brutal. Most researchers called it a violation of Occam's razor, invoking alien technology before exhausting natural explanations. Some called his methods naive. Others called his media strategy irresponsible. But here's the uncomfortable truth most documentaries won't tell you. The light sail idea was rejected by most researchers, but the case did not close cleanly. Science does not work by simply laughing at a hypothesis until it disappears. You need a better explanation that accounts for the same strange data. And for years, every natural explanation solved one part of the mystery while leaving another part exposed.
In 2020, Seligman and Laughlin proposed that Oumuamua was made of frozen hydrogen, H2 ice formed in a cold molecular cloud. Hydrogen gas is invisible, so the outgassing would be undetectable. Elegant idea. One problem. A hydrogen iceberg would evaporate long before reaching our solar system. Harvard's Center for Astrophysics ran the numbers. It couldn't survive the trip. Theory dead. Theory 2, the nitrogen ice pancake. In 2021, Desch and Jackson from Arizona State University suggested Oumuamua was a shard of nitrogen ice chipped off the surface of an exopluto, a Pluto-like world in another star system. Nitrogen sublimates invisibly. The shape matches. The color matches Pluto's surface almost exactly. The problem? You'd need an absurd number of Pluto-like worlds ejecting nitrogen chunks into interstellar space for one to end up here. The production rates don't add up.
Theory 3, and currently the most accepted. In 2023, Bergner and Seligman published in Nature that Oumuamua was ordinary water ice, bombarded by cosmic rays during millions of years of interstellar travel. Those cosmic rays broke water molecules apart, trapping hydrogen gas inside the ice. When Oumuamua got close to the sun, the trapped hydrogen escaped, an invisible jet that pushed the object without leaving a visible trace. It's the neatest explanation. It doesn't require alien engineering. It doesn't require exotic ice, just water, time, and cosmic rays. But wait, there's still a problem with all of this. Every one of these theories, hydrogen iceberg, nitrogen shard, water ice with trapped gas, every single one requires something we've never observed anywhere else. A cosmic process we've only ever had to invoke once to explain exactly one object. None of it has been confirmed, because we can't go back and check. Oumuamua is gone. It is currently far beyond the outer solar system, moving at roughly 26 kilometers per second, and still receding.
It is now billions of times fainter than when we first spotted it, well beyond the reach of even the James Webb Space Telescope, the most powerful observatory ever built. The most optimistic intercept mission ever proposed, Project Lyra, would require a Jupiter gravity assist and a solar Oberth maneuver. Depending on the trajectory, the earliest proposed arrival windows fall somewhere between the late 2040s and mid-2050s, with technology that doesn't fully exist yet. We had weeks. We had a handful of telescopes, and then it was over.
The first visitor from another star in the entire history of our species. And we watched it leave, with more questions than answers. Possibly forever. Because here's the part that keeps some astronomers awake. Whatever Oumuamua actually was, rock, ice, or something we haven't named yet, we're never getting another look. Not at that one. Not ever.
In August 2019, amateur astronomer Gennady Borisov spotted a second interstellar object, 2I Borisov. Unlike Oumuamua, it behaved like a perfectly normal comet, a coma, a tail, water and carbon monoxide. Nothing unusual at all, which made Oumuamua seem even stranger. Then, in July 2025, a third interstellar object, 3I Atlas, entered our solar system. Another active comet. Methanol and hydrogen cyanide detected. Again, completely normal. 2 out of 3 interstellar visitors behave exactly as expected. 1 doesn't, and it was the first one. The Vera Rubin Observatory is now beginning the survey era that should reveal many more faint, fast-moving visitors. Sooner or later, another Oumuamua will come through, and this time, we'll be ready. In 2017, something crossed our solar system for the first time in human history. It was small, dark, strangely shaped, and moving in a way we couldn't explain. We named it the Messenger, but we never decoded the message. Was it a chunk of nitrogen ice from a dead Pluto? Was it water ice holding trapped hydrogen? Was it something built by hands that weren't human? We don't know. We may never know. And that might be the most honest answer astronomy has ever given. Here's what most people will never understand. For 11 days in 2017, our species shared a solar system with something from another star. And then it was gone. Forever. You now know a story that most humans walking around today have never heard and never will. If that thought made you look up at the sky a little differently, stay with the channel. The next question is not what passed through our solar system, but what reached out and touched us. In December 2004, a dead star 50,000 light-years away physically disturbed Earth's atmosphere. Most people on Earth never knew it happened. You will.